Okay, this is another example of the Doppler effect, only this time we're going to have both the source and the observer moving. And so this time it says a police car moving at 40 meters per second is chasing a speeder. All right, so I'm going to draw two cars here. All right, so let's make this the police car. And so we'll put a little siren on top. Or actually the lights, I suppose. And there's my speeder. All right, so this is going to be the police car, and I know that the velocity of the police car is, 40 meters per second. And I know the velocity of the person inside the car is going to be 30 meters per second. Now, which one is your source and which one is your observer? And since it's the police car who's got the siren, this is actually going to be my source. So the police car is going to be the source. And so the guy being chased is going to be the observer. And he's moving at 30 meters per second. All right, so let's just draw little arrows representing which way he's going. So let's say that the speeder is going to the right. Well, if the police car is chasing him, he's also going to the right. And then last but not least, I know that the horn, which is the frequency of the source, so I'm going to call that F prime, is 300 hertz. And now we're asked to find what's the frequency heard. What does the guy inside the car hear? All right, so let's take a look at this. So we're going to start with our equation for the Doppler effect. And I always start with the equation because you have to remember that you're going to be given more credit for the values that you put into the equation than your actual math skills. So always keep that in mind. All right, so now I put in the frequency of the source, which we said was 300 hertz. The V that's by itself is the speed of sound in air, and unless you're told otherwise, let's go ahead and use 345. All right, now this is what we got to think of, the observer. The observer is going away from the source. And if it goes away from the source, the frequency is going to be smaller. So the frequency here is going to be less. Therefore, I have to subtract the 30. But if you can't remember this, remember you can use the old video where it has all the signs that you want to use. So I would have that set aside someplace so you could refer to it. All right, now let's do the denominator. The speed of sound is still 345. But this time the source is going towards the observer. Now, since the source is going towards the observer, I want that answer to become bigger. But I'm still going to subtract it, and I'm going to subtract it because it's in the denominator, and when it's in the denominator, I actually want that value smaller. We plug this into our calculator, subtract 345 minus 30, 345 minus 40. We put it into our calculator, and I get 308 hertz. Now, it's still higher than the police car, but not much. And why do you think that is? Why do you think that the police car still wins? It's still going to make it higher. All right, think about this. Good luck.